Hello, ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. We are in section 2.2, which is going to be solving equations by multiplying and dividing. So let's write that down. Solving by multiplying and dividing. Now, if you remember from the previous lesson, what does it mean to solve? To solve means to get everything on, or your variable on one side and everything else on the other. So, in the previous edition, we were working with just addition, or addition with a negative number, which we call subtraction. And to solve those, we got rid of the addition or subtraction by adding or subtracting. So if you think about that, if you get rid of addition by addition, how do you think you're going to get rid of multiplication? Well, you're going to get rid of it with multiplication. So let's just jump straight into the examples, because on this one we already know what solving means. We don't have to go over any new definitions. We just have to figure out how to solve by multiplying. And the best way to do that is to look at a few examples. Let's look at a super simple example. Let's look at negative 4 is equal to k over negative 5. And we are told to solve for k. All right, so we're told to solve for k. Now when we're looking at it, here's k. Say hi, k. All right, there's k, and we want to get k by herself. So who's hanging out with k? Well, Mr. Negative 5 is hanging out with k. In fact, he's hiding in the bushes under where she's supposed to be, and she is very upset about this. After all, every time a girl has somebody hiding under them, they get a bit upset. I don't blame them. So we need to get rid of this stalker Negative 5 guy. Now, how do we get rid of our little stalker Negative 5 guy? Well, to get rid of multiplication, you multiply. So in this situation, I would take both sides and I would multiply them by whatever is on the bottom. In this case, negative 5. So I'm going to multiply both sides by negative 5. And when I do that, remember how to multiply a fraction by a whole number? You divide by the bottom and then multiply by the top. So what is negative 5 divided by negative 5? That would be positive 1, right? A negative times a negative is a positive. So negative 5 divided by negative 5 is 1, and we multiply 1 by k, and we end up with k all by her lonesome. Now on the other side, we now have negative 5 times negative 4. Again, a negative times a negative is a positive. So we're going to have a positive answer, and we're going to have 5 times 4, which is 20. Now is k solved for? Have we solved for k? Is k by itself? Well, there's nothing in front of it. There's nothing beneath her. There's nothing above her. She is all by her lonesome self, and she is happy. She is so happy to be alone. It's like after being at a party for way too long and your ears are ringing and you just want to go home and be alone for a minute and go to sleep. That's what K's situation is. And she is happy because she's all by herself, and then there are 20 over next door. So we have solved for k. So a little note over here is that when you have something on the bottom that you want to get rid of, something on the bottom, we would call that the denominator if we were Mathanese, but, hey, to each their own. So when you have something on the bot and want to get rid of it, multiply both sides by whatever's on the bottom. In this case, k had a negative 5 hiding underneath her, And so we said, k, let's get you by yourself. We multiplied both sides by -5, which is the exact same thing that was on the bottom. And when that happened, they eliminated, they canceled, they turned into 1. And when you're dividing by 1, it just goes away. We don't bother because we can always divide by 1. So we don't write that it's really k over 1. We just write that it's k. And then on the other side, we have the -5 times whatever is there. We do some evaluation on that side, and we get positive 20. So whenever you have something on the bottom and want to get rid of it, multiply both sides by whatever is on the bottom. If you do that, you will always eliminate what's on the bottom. Always. It's like an amazing trick. All right. Let's look at another example. And this time we're going to give k a break, and we're going to go after Mr. M. And Mr. M happens to be divided by 3 at the moment. And we're trying to make that equal to, oh my goodness, it's a decimal, 1.5. Oh boy. Oh boy, I hate decimals. They always lie to me. But that's okay. We'll live with it. We'll have to say, all right, what do we do? What do we do? We got the 3 hanging out underneath Mr. M. Mr. M doesn't like it. Mr. M's saying, 3, please go away. So how do we make Mr. 3 go away? That's right. Multiply both sides by 3. 3 divided by 3 cancel out. We are left with m on the left. And on the right, we have 1.5 times 3, which is, I believe, 5, but I'm not certain. So I'm going to double check on that. 1.5 plus 1.5 plus 1.5 is going to be 4.5. So I was wrong. It's 4.5. My apologies for all you math Nazis out there. I can't do arithmetic. I still have to count on my fingers. But I can still do math. And math says, multiply both sides by 3. Bam, they eliminate on the left. I'm left with just Mr. M by himself. On the right, we are left with just 4.5, and we are done. Now, could we change 4.5 to a different fraction? Well, sure we could. We could totally change this to 9 over 2 if we wanted to. But in this case, because we started out with a decimal, we can go ahead and end with 1. So we're not going to have to convert it into 9.9 halves, even though that would be Mr. O'Neill's preferred format. All right. 2 examples down. Now let's see what happens when we have something that isn't being divided. Let's look at what happens when we have 7x is equal to 56. Now, some of you already know the answer to this question. 7x is equal to 56x. What is x equal to? And they'd be like, well, it's 8, Mr. O'Neill. I'm like, yes, it is. I agree. But we got to show our work. We got to show how we get there. So we got the 7 hanging out with x. And x and 7 are going to have a big breakup because x is way too independent. Doesn't care about 7 or how pretty she is, only cares about himself. And so 7's like, okay, I'm done. I'm out of here. And to get out of here, we have 2 options. The first option is to multiply both sides by 1 over whatever that number is. So in this case, we have 7, so we'd be multiplying it by 1 over 7. When we multiply both sides by 1 over 7, 7 divided by 7 is 1 times 1 is 1, so I'm left with just my x on the left. And then on the right-hand side, we have 56 divided by 7, which is 8, times 1, which is 8. And we get x equals 8. So that's option 1. And as a mathematician, I think option 1 is better. Much better. Way better. It's far superior to option 2. Option 1, when you get used to multiplying by 1 over whatever that number is, or the reciprocal of that number, it becomes so much easier when you're dealing with large fractions or Franken fractions. So there's option 1. Where's option 2? Option 2 says we have 7x is equal to 56. But instead of multiplying by 1/7, we divide both sides by 7. 7 divided by 7 is 1. We're left with x. 56 divided by 7 is 8. Do both lead us to the same location? Well, yes. Yes, option 2 does work. But option 2 has a problem when it runs into fractions. When you have a fraction in front of the x, multiplying the x, then option 2 starts to be a little more ambiguous, meaning that it's not like clear cut. Whereas option 1, where you always multiply by the reciprocal, always works. It's just easier to remember. So go ahead and do option 1 if you can. And if you can't, you may use option 2. They're both very similar at this level of math. But note that if you do option 1 all the time, like you'll get these things on your paper. And I think everybody loves falling bananas. Or just smiley faces. I'm not sure which. Anyway, you get a lot of smiley faces if you do option 1. Maybe even some stickers. I don't know yet. I have to talk to my wife about getting more stickers because she is awesome. All right. Now let's look at that final technique, that final piece that I was talking about, where you had a fraction in front of the variable. Let's say that we're told to solve for v. And we are given that 5/9 v is equal to 35. And at this point, if we go with option 1, option 1 says, I'm going to put it over here for option 2 too, not to be confused with A22, which is something that ballerinas wear. So let's go back to option 1. And I'm going to do option 1 in green because green's really awesome of a color. I love the color green. So we have 5/9 v is equal to 35. If we do option 1, where we multiply both sides by the reciprocal, we would multiply both sides by 9/5, or 9/5. When we do that on the left, 5 cancels with 5, 9 cancels with 9. We're left with just plain old v. On the right, we have 35 times 9/5. And if you remember how to multiply a whole number by a fraction, divide by the bottom, multiply by the top. 35 divided by 5 is 7, so I'm going to put a little 7 over here to remind me. And then 7 times 9, using your fingers, count over 7 places. 1, 2, 3, 4, 5, 6, 7, and we get 63. So 9 times 7 would be 63. See how easy that was? Now, what about option 2? Well, option 2 says to get rid of a number on the bottom, you multiply both sides by that number. Or to get rid of a number on top, you divide both sides by that number. So we're going to start out by doing one of those things. We are going to multiply both sides by 9. Now, when I multiply both sides by 9, the 9's cancel. I am left with 5v is equal to 35 times 9, which I pull out my calculator and say, Mr. Calculator, what is 35 times 9? It tells me 315. In which case I say, well, time to go. I'm like, oh yeah, no, not at this school. Oh well. Now I have 5v is equal to 315. I still have something hanging out with my variable. I need to get rid of it. So to get rid of it, I have to divide both sides by 5. So I divide both sides by 5. And I get v is equal to 315 divided by 5, which gives us, you guessed it, 63. Now, in both of these cases, do we end up at the same location? Well, on the left-hand side, option 1, we ended up at 63. But how many steps did it take? How many lines worth of work did it take? Just one. What about in option 2? Well, in option 2, we had our first line, and then we had a second line before we could get to where we needed to be. So option 1 saves space and time and is easier. Option 2, if you need to break it down and do every piece individually, go for it. There is nothing wrong with option 2. If you need to do every single piece one line at a time, that's absolutely fine. You should have seen some of my differential equations homework in college. It was about 14 pages long per problem because I would show what I did on every single line. And then sometimes I would get lost and I'd have to redo it, and then I would have to show every work on every step on every single line. But that's fine. That's good. That's why my differential equations instructor didn't completely hate me, was because I showed my work so well. And of course, every time I handed him a giant book worth of a packet of paper while everybody else is like handing in like 2 sheets, he would just look at me and shake his head, but it still helped. It helped me, it helped him. We both could see where I messed up. He could point it out to me in like 2 seconds because he was amazing, and then it would take me about 3 hours to figure out what happened. So it happens. It's all right. We can do it that way. If we need to show every step, it's just fine. All right. And guess what that means? Yay, we're done. Woo! All right, practice time. Most exciting time of the day. All right, this is going to be section 2.2 on page, it should be page 87, but again, different books tell us at different pages. Just know that it's section 2.2. That's all you really need to know. And then let's do numbers. 1 through 17 odd. 19, 23, 25, 29, 31, 33, 35. Oh, that should be a 5. And that should be a 3. And because I really love word problems, we're going to do 45. 52. Sorry, 53, 55, and 57. Not to be confused with the ketchup. All right, so 1 through 17 odd, 19, 23, 25, 29, 31, 33, 35, 45, 53, 55, 57, and we're done. All right, practice, practice, practice. Good luck and have fun.